So yes, we are here today to speak about unlocking the future of data-driven collaboration, especially regarding open science and industry innovation. So as I mentioned, this workshop is co-organized by EMMC and the MatCHMaker project, and I'm going to say some words. So first of all, welcome in Paris. It's quite hot, but in any case, we are very happy to welcome you today in Paris. And I think this day will be very rich in terms of communication, network, and exchange. I would like, first of all, to present you very quickly our MatCHMaker project that will be better presented in a dedicated slot just after. We had during this project that ends in 2 days, different objectives combining both scientific and non-scientific objectives. And the first idea was really to develop a model-based innovation process to accelerate advanced materials design and validation, novel characterizations, and modeling. So the main point was to understand the link between properties and complex microstructural features, accelerate multi-phase, multi-scale materials design, and also include in the demonstrations the material sustainability assessments. So that's for the general scientific part, and combined with this scientific objective, we really wanted to reinforce traceability, integrity, interoperability, and it will be really a part of our presentation today, both into characterization, modeling data, workflow, especially by the development of material ontology. And by the way, we wanted to make our knowledge and data really accessible by developing the open data repository that will be also presented during the dedicated session. We had 3 main use cases in our project. I'm not going to go into very detailed, much details, but globally we had a first construction with cement industry supported by Heidelberg Materials, with the objective to decrease dioxide carbon emissions and the waste of cement production. The second use case was about energy solid oxide fuel electrolysis cells with our industrial partners, which is Genvier, to produce hydrogen without dioxide carbon emission and to achieve the highest efficiency. And finally, the third use case was about mobility with proton exchange membrane fuel cells, with the objective to produce zero emission power in multiple applications. So what is to be understood is that the scientific developments that have been done during our MatCHMaker project was really dedicated to fulfill these industrial objectives by a global identical similar methodology. So the methodology was based on the 3 main pillars. The first one was about advanced data acquisition, especially to evaluate microscopic and macroscopic quantities of interest for our 3 use cases. The second scientific pillars was machine learning tools to reduce especially the time for acquisition and estimate the link between microstructural and macroscopic properties. And finally, we have physics-based model, advanced models, like multi-scale models and correlation with sustainability and social impact. So really, we wanted to make advances, progress on these 3 scientific pillars to go to the final industrial objectives of the project. As soon as we use complex approaches, we need to be careful about the validation, and we try to implement a robust validation process with, when possible, confrontation between machine learning tools, advanced modeling tools, and experimental results, and also the validation of key performance indicators, especially by end users, to include also sustainability assessment of the new materials. As I mentioned just before, we had also a big part of the project which was related to knowledge transfer, especially through the development of semantic interoperability with the development of domain ontologies, especially on characterization. Data sharing with the development of an open repository that will be demonstrated just after the introduction part of the meeting. With a storage and quick access to data combined with a uniform and interoperable manner to create and access the models. And finally, standardization activities to see what is missing, what is currently missing is the standards related to the topic of interest of MatCHMaker project, to perform landscape analysis and recommendation for improving the existing standards. So that was for the general presentation of the project. Obviously, MatCHMaker was among other sister projects with different use cases, but more or less the same objective, at least a global objective. With in each case projects which are based on data-driven collaboration, encompassing both data production and data analysis. And really the question we had about it is how to make the most of data-driven collaboration. So it comes to the following questions that we will try to discuss during our day. First of all, how to encourage industrial adoption of the project results, which means that once the scientific products has been done, how to encourage that they will be adopted by the industries. The second question is how to support data life cycles, including non-technical adoption barrier. So there will be a presentation about a white paper on data life cycle. And finally, how to implement and develop data interoperability and sustainability, especially in relation with the development of our open repository. So this comes to the final two agendas that is going to be followed today. So we will try to discuss, at least answer perhaps, some of the questions I have just mentioned. And well, it will be really the objective, and the objective obviously is to develop network, communicate, and so on. So I hope you will enjoy the day, and I hope that it will be helpful for everybody. So thank you for that. I'm going to give the floor to Isabelle Chataigner that will give the introduction speak. And Isabelle is from the French Ministry of Research and Aerospace Technology. Yeah.
Thank you, Ludovic. So I'm very happy to be here today to express the strong interest of the French Ministry of Higher Education and Research and Space. So the strong interest that this ministry has taken in a project such as this one, which brings together, if I'm not wrong, 12 public and private partners and 8 European countries around, as says the title, advanced materials characterization and modeling, aiming at matching the needs of the EU manufacturing industry. And this represented a strategic opportunity to develop an innovative approach to material science driven by industrial needs, and we fully support this type of initiative. As you are probably aware of, with a budget of 4.7 million euros that were fully funded by the European Union and implemented over 3.5 years, this project is a research and innovation action and belongs to Pillar 2 and Cluster 4 of the Horizon Europe Framework Programme for Research and Innovation. And I would like to emphasize here how closely this project aligns with the French priorities. Indeed, France considers this cluster, Cluster 4, essential to strengthening and the sovereignty and competitiveness of the European industry. And in particular, advanced materials are recognized as a key driver for innovation, resilience, and industrial leadership in Europe. This MatCHMaker program also fits very well with some European objectives, such as the one described in the 2024 Net Zero Industry Act, which builds a framework for development of the net zero technologies in Europe, with the aim of meeting European demand with 40% of locally made products by 2030. And this act, as you may know also, is currently being reinforced with the Industrial Accelerator Act, which will soon come. So the ambition of your project deserves special recognition. It brings modeling and characterization closer to industrial realities, with the objective of avoiding lengthy and expensive intermediate characterization steps. And MatCHMaker has thus proposed a truly forward-looking methodology based on the intelligent use of proxies. As highlighted by Ludovic, the strength of your approach is the combination of advanced experimentation on microstructural characterization of materials, physics-based modeling capable of predicting properties, and the creation of standardized databases enabling machine learning analysis. Another major asset of the project is the relevance of its 3 industrial use cases, all driven by the shared objective of reducing carbon dioxide emissions. This is done through optimized cement production, membranes for electrolysis cells, and membrane for fuel cells also. So each of these use cases successfully brings together industrial companies and academic partners to address challenges with immediate practical impact. This project is really ambitious because it integrates material designs and manufacturing approaches across several strategic sectors that are construction, energy, and mobility. And by promoting interoperability through fair data principles, MatCHMaker contributes to a more integrated and efficient European research ecosystem. This project also demonstrates a clear commitment to structuring characterization and modeling workflows strategically by promoting standards, facilitating knowledge sharing across Europe. And the selected use cases perfectly illustrate the practical and cross-sectoral dimension of the project. And I would also like to underline the importance of your work on data sustainability and consistency developed within a computational ontology framework, which will contribute to broader European initiatives on open and interoperable data repositories. As far as I know, this collaborative effort has already led to several scientific publications. More are currently underway. And maybe I'm wrong, but I think it has not resulted in industrial deployment really at the moment. But I'm sure this project has definitely strengthened cooperation between stakeholders and laid the foundations for continued coordinated progress. And that's really important. And for this reason, I would like to conclude by wishing the MatCHMaker project, or rather the many initiatives and collaborations that will emerge from it, a long, impactful, and successful future. Thank you.